Okay, let's look at some exercises. Number 19. It's about determining whether this matrix is invertible or not. Is A invertible? Now, as we see, this is an upper triangular matrix. And for an upper triangular matrix, we only have to look at the diagonal elements. And if they are all non-zero, then the matrix is invertible. This is not the case, so the answer is no, because of this 0 here. Number 25. Here they ask us, when is this matrix symmetric, which means that it's equal to its own transpose. So the transpose of this matrix, let's just write it up, is 4a plus 5. The column becomes a row, and minus 3 minus 1. This column becomes this row. Now the two have to be equal, so we see that the only condition is that we have actually two conditions, that this is equal to that and this is equal to that, but these are the same conditions, so this is a plus 5 equals minus 3. We solve, a is minus 8. That's the answer. This is homework from 8.1, number 15, and this is a transformation they give us with equations. So now they ask us, what's the matrix of this equation? Now, it's very easy because we can read this off from, these are the coefficients of the system of this linear system of equations. Of course, no coefficients means 1. So we see that the matrix is 3, 5, minus 1, 4, minus 1, 1, 3, 2, minus 1. Okay, just to show the last row here, this 3 is this 3, this 2 is this 2, and this minus 1, of course, is a minus 1 here. Okay, that's our matrix. Then they ask us also, what is T of, 15, of minus 1 to 4? Well, we can either now plug, so this we put in x1, this is x2 and x3. So we can plug that inside these equations. I'm going to do it only for the first one, so I'm only going to calculate with W1. W1 is 3 times x1, which is minus 1 here, this minus 1. Plus 5 times x2, which is 2, times 2, this is times, plus 4 times, plus 4, minus 1 times 4. So this would be minus 3 plus 10 minus 4, that is 3. But we can also do this quicker. We can use the matrix. Let me do this just here. So we do this matrix here now. And we just put here the column, the vector, now written as a column, minus 1, 2, 4, and we just do the matrix operation. So we do 3 times minus 1, 5 times 2, minus 1 times 4. That's of course the same number that we had previously, and this is the first row. The second, now we do the second row, we do these two. I'm going to just write down the numbers, minus 4, minus 2, plus 4. And then the last row, this row times this column, is minus 3, plus 4, minus 4. So this would give me in total, with the first one we had already 3, the next one is minus 2, and the last one is minus 3. So that's the image of, so this is T of minus 1, 2,